There are two atoms, if you will, of the same color on the left side, on the reactant side, and only one of that same color on this side. So I hope you can see that we're going to need a 2 here to balance the number of blue with the number of blue here. And then that will give you 2 of these, which will balance the red ones.
It should be 2, 2, 2, 2.
It should be 1, 1, 2.
Oh, I did 1, 1, 1.
So let's put that without the positive sign. So one of these, comma, one of those, comma, 2. But again, this indicates that there's only one of these. So there's 2 of those, but 1 of the whole thing. 1 of those, but 2 of each. I mean, 2 of the one, and then 2 times those 2. Everybody's on the same page? Okay. Just in case you encounter this question, because since you didn't see it in the homework, I don't feel like it's not fair. So let's see if that's... So you're going from 2 different kinds of molecules to 1. That, to me, always tells me combination. So when you're combining one type of element with another type of element, you're getting a new molecule. That's a combination reaction. So in the next example, we'll see a different one. I'm going to choose combination, submit, and then we'll check the answer. Now, here seems to be a different idea. One is splitting into 2. So this is going to be a decomposition reaction because you're going from one type of molecule to 2 different ones. Okay? Now, let's count the same color circles for both sides. There are 2 of the blue ones, 2 of the blue ones. So that's balanced. But there's only 1 of the red ones here, and there are 2 over here. 1, 2. So we need to do something to balance it. If we put a 2 here, so we're going to go first with a 2 of those yielding. Now, what did I do for that? So those are these, the dark ones, and that one plus 2 of those. I hope it's the same question on the final exam if it shows up, but if it's different, just please take your time to analyze it and make sure that logically you can explain the way you balanced it. So let me put the numbers here. And I'm going to call it a decomposition because you're getting 1 molecule becoming 2 molecules. So it's decomposing, it's breaking away. And let's now take a look at the answers. So for that, I think I had to change to solution view. And yeah, so we got them right. Okay? So redox means reduction oxidation or oxidation reduction. And it depends on the area of chemistry that you're studying. You look at different things to determine whether you are looking at a reaction that is undergoing oxidation or reduction. Now, we need to define those 2 terms. Here is where the confusion arises. So, oxidation. in plain English, when you look at iron or something made of iron, a nail, and it becomes rusty, it goes from being shiny to being kind of reddish, we say sometimes that it has been oxidized. So oxidation and oxidizing are the same thing. It means that something has transformed the iron from one type of ion to another type of ion. Sounds like a tongue twister. But in a definition dealing with electrons, this is how we define it. The loss of electrons by a chemical species. Now that's one definition. We're going to look at more than one definition to help us understand the terminology. The opposite of losing electrons, and here is where the confusion arises, is going to be the gaining of electrons. And that does not make logical sense. The gain of electrons by a chemical species. And by chemical species, I mean any chemical, from an element, ion, molecule, etc. Now, please stay here with me because this is where it's confusing. When you reduce something, at least I sometimes combine Spanish with English and think of the word in two different languages, but to me reducing means getting less, right? If you reduce the size, good morning, if you reduce the size of, I don't know, a piece of wood, that means that you're chipping away wood, so you're making it smaller and smaller. But here we are saying gain. So that doesn't make any sense. The problem and the reason for that apparent disagreement is because the way of the term reduction was first used. And let me show you how it was first used. So we're going to start with iron here. That's a good element to use. And if I go to the periodic table and find iron, I realize that according to the periodic table, iron can become iron 2 plus or iron 3 plus. There are two possible oxidation states, conversions of iron to an ion of iron. Let me put a charge here. So this is the charge for those two chemical species. In the periodic table, iron, atomic number 26, is going to have 26 protons and 26 electrons, equal number. That's why the charge of iron from the periodic table is 0. Okay? Now, iron can become iron 2 plus. Now, what happens when that takes place? Well, 2 electrons are being released. Now let's do the math. From the periodic table, iron had 26 electrons, but now it's losing 2, so it's going to have 24 electrons, still 26 protons. 26 plus 24 minus is going to give you 2 plus, this sign that you see right here. So what in reality is happening is that this guy, in becoming iron 2 plus, is what is it looking to you that is happening? I mean, what's happening to the number of electrons is losing electrons. So by definition, this is an oxidation. So iron is oxidizing to iron 2 plus. So oxidation. Now let's rewrite it now in the reduction direction. So now we're going to do the opposite. We're just going to flip this completely. We're going to say Fe2 plus, which is an ion. When you add 2 electrons to it, I'm adding now electrons, it's going to become Fe0. The ion now becomes the element on the periodic table. It picked up 2 electrons, and this is called reduction. Gaining electrons is reduction. Still confusing, right? Now, look at the charges. What happened to the charge of iron in the reduction example? It went from 2 plus to 0. It got reduced. The charge is what is being reduced, not the number of electrons. And that's why it's confusing. Because when they first described the term reduction, they were looking at the reduction on the charge, not at the number of electrons. So to help us with that, and last time, I think it was you, Lisa, contributed one little mnemonic, one little phrase to remember, so that you don't have to go through all of this every time that you look at an equation. You just remember one of two things. Either you remember oil rig. You know, we don't live in an oil-producing state, but down south, states like Texas, they have oil rigs everywhere. So people know what is an oil rig. You guys maybe never seen an oil rig. If you've never seen one, it's just that little tower that extracts oil from the ground. But the point is that if you remember this oil rig, this is going to remind you. That's where the oil comes from. And rig, the reduction is gain. That's where the rig comes from. So you can try to remember that and then rely on that to determine whether or not an equation is a reduction or an oxidation. Now, the second one that I can give you, I remember it a little bit better, is Leo the lion goes. Maybe this is more for elementary school. I don't know. Leo the lion goes grr. Sounds silly, but it helps me, believe it or not, remember. Leo is loss of electrons, oxidation. So Leo. Grr, gain of electrons, reduction. So when you look at an equation and you use one of those two little phrases to help you, you can see what is going to be called. Iron here is losing electrons, therefore is an oxidation. I'm going to give you another example in which you're going to have to determine it by looking at either the definition or those acronyms. But that's what it is. It's not that difficult once you know how to approach it. Now, unfortunately, oxidation reduction is not always clear if you only look at electrons. But in this class, the good news is that we're going to be looking mostly at charges and electrons, so it should be okay. Let me erase these and give you another example and ask you the question to predict whether that is an oxidation or a reduction. And I'm going to make another choice here. Okay. So I'm going to use this time Cr, chromium. And chromium starts with a charge of 3 plus, so this is the ion. And in this example of a reaction, it's going to be transformed into chromium 0, which is the one that you find in the periodic table. So this is the charge before the transformation, before the reaction, and this is the charge after. How do we go from having a charge of 3 plus to a charge of 0? Do we add or remove electrons? So if I take 3 electrons here, let's see what happens. I'm removing 3 electrons from here, adding them to chromium. Does that make sense?
Oh, it's the other way around.
So we have to be very careful. Let's put it in numbers. So chromium, atomic number 24. So chromium 3 plus has 24 protons. And to be charged with 3 plus, it must have only 21 electrons. Okay? So chromium 0 has 24 protons and 24 electrons. So to go from 21 to 24 electrons, this is not the way it has to happen. We had to add electrons. So what's happening essentially here? We're adding electrons to chromium, is gaining electrons, therefore is a reduction. So let's label it. And that is exactly what it is. I mean, don't feel bad, Jason. This was a really, really tough one. I have to think 2, 3, even 4 times about it every time, and I need to scratch my head and look at it again. But now, with the definition of the charge becoming less positive, that confirms that it is indeed a reduction. So the 3 plus is becoming less positive. There is a reduction. Yes?
Didn't you say that the number of electrons wasn't changing?
The number of electrons can change. The number of protons never changes. Yes, so thanks for that clarification. The number of protons cannot change, because if it changes, you change the element. It's no longer chromium. But electrons can come and go. You can add, remove, or they can stay the same. Okay, now, we're looking at this individually, one element or atom at a time. In chemistry, this happens at the same time as an oxidation is happening. In other words, when chromium gets reduced, it has to be picking up the electrons from somewhere. It's not picking them from the environment, it's picking them from another element. So typically, when you have a reduction, you have also an oxidation happening at the same time. Both are happening at the same time. Oxidation, reduction always go hand in hand. But the key here in this chapter is to identify the species that is being oxidized and the species that is being reduced. So let me go and find a problem in which we had to do that. It'll be a little bit easier to understand when you look at a problem. We'll go back and answer all of these questions, but first we need to get rid of the idea, or understand the idea of oxidation and reduction. I'm almost there. Okay. Not that one. Not that one. Right here. So I'm going to put that reaction on the board so that we can actually do some thinking. Now start looking at it They can get a little confusing, but if you analyze it carefully, you should be able to figure it out. So copper is combining with silver. Ag stands for silver. The silver is an ion, and it has a charge of 1 plus, and is indicated to be present in the presence of water. So the AQ means aqueous, if you recall. Now that, when the two react with each other, get transformed into the copper ion, 2 plus, which now is going to be in solution, aqueous, and the silver becomes a solid. And to balance it, we have a 2 here. Now let's complete it with something that is not on the problem. It's not shown on the problem, but we can easily show it. Whenever the element doesn't have a charge shown, so here silver is shown with a charge of 1 plus, here copper is shown with a charge of 2 plus. If they don't have a charge, you assume that the charge is 0 immediately. So this copper has a charge of 0, this silver has a charge of 0. Now let's take a look only at a pair at a time. So we're going to see what happens to copper from here to here as far as electrons is concerned. I mean, think about it. Now we know from the explanation that I gave you a few minutes ago that if the number increases, that's going to be oxidation. If the number goes down, that's going to be reduction. But let's look at it in terms of electrons. Copper, periodic table 29. So copper right here has 29 protons and 29 electrons. Right? That's copper 0. Copper right here, to be 2 plus, the number of protons cannot change. So it still has to be 29 P positives. But now it's more positive, meaning it has more protons than electrons. So it must have 27 electrons. 2 less electrons. So what happened to go from here to here? It looks like it's lost electrons, right? So loss of electrons. What is loss of electrons? So we're going to call this oxidation. And copper is going from reduced copper to oxidized copper. So when something is oxidizing, it has to start from the reduced form. So I'm going to put here the word red for reduction and OX for oxidized. This guy was reduced, it oxidized to copper 2 plus. Let's double check. Let's go to silver now. Silver in the periodic table, see if I can find it, Ag. Okay, 47. So silver has 47 protons. 47 protons. And in the case of silver with a 0 charge, must have 47 electrons. To have a charge of +1, it must have 1 more proton than the number of electrons. So this must have 46 electrons. Okay? Now, what is happening from having 46 electrons to having 47 electrons? It gained an electron. The gain of electrons is a reduction. So this is a reduction. For silver. Therefore, this guy is oxidized, OX, and he became reduced. The charge is going down, which makes sense. to silver 0. To make a little bit more clear, I'm inserting here a word that I perhaps shouldn't. Identify the reactant that is being oxidized. In other words, that starts reduced. This starts as reduced and is being oxidized. This guy starts as oxidized and is being reduced. You see that? And I believe that's what the question is asking. Which one is becoming oxidized? Poorly written. Now, let me ask you a favor. Ignore the way the question is written. Let's go back to our diagram here and help me identify some species with my own question. Let's look at the reactant side, not at the product side. I mean, everything is labeled, so I'm going to have to erase this, give you a new example, and then I'll ask you the same question. But for now, here we go. Of those two on the reactant side, which one is reduced right now? The copper, absolutely. I mean, we labeled it. In fact, let me write reduced.
So you would say it's reduced even though nothing's happening?
Right. Yeah. It's in its reduced form. Okay. How can I say it in a different... Absolutely, that's a very good point.
The original state.
The original state is reduced. Right. The original state, that's a very good way of putting it. The original state of copper, before anything happened, is in its reduced form. So we need to think of two states, either reduced, and by the same token, the silver, before anything happens, is in its oxidized state. But now it's going to become reduced. I mean, it is somehow cumbersome. So let me ask you another question. Only on the reactant side, before any transformation happens, which of the two species, copper or silver, is in its oxidized state? Silver. So that's a little bit more clear when we put it, with your help, in better terms than this sort of misleading question. At the end of the day, what is important is to understand the transformation. So I'm going to erase it and put a new one, and then I'm going to ask you the same question that I just did, because I want you to feel confident looking at these reactions. So I can use the next question as an example here. So, can I erase this? Okay, let's put and label and logically think of what's going on with this first one. These are half reactions, by the way. They're not complete reactions. In the other one, we had a complete reaction. In fact, chromium 3 plus becomes chromium 0. And before I put the electrons that are already here, you tell me where the electrons go. So are we adding electrons to chromium 3 plus, or are we adding electrons to chromium 0? All you had to do is go back to the periodic table and do the accounting. This has 24 protons. This has 24 protons, always. That doesn't change. To be 0, this has to have 24 electrons. To be 3 plus, it has to have 3 less electrons than 24. So it must have 21 electrons. So how do you go from 21 electrons to 24 electrons? You had to add 3 electrons. So that's why this has plus 3 on the left side. So we're going to say 3 electrons plus chromium 3 plus becomes chromium 0. Now let's do the labeling. What is happening to chromium in this direction? Right, so let's label these guys. When you gain electrons, it's a reduction, right? So this guy right here is the oxidized form. This right here is the reduced form. So is it really oxidizing? I think it's getting reduced. Okay? So this is a reduction. There's nothing wrong with guessing wrong once you review the answer and realize, wow, it's not an oxidation, it's really a reduction. And again, it's misleading because of these 3 plus and this 0. How can that be a reduction? Well, because the reduction is on the charge, not in gaining or losing electrons. And that's the conundrum here. That's the confusion. But with that all labeled, can we drag that? Let's see, what is the question exactly? Question. Drag the appropriate items to their respective bins. So what is this describing? This is describing a reduction. So we're going to drag that first one to a reduction. Let's take a look at the second one. I don't need to write it down. We're now going to look at barium is gaining electrons, right? The gain of electrons is a reduction. So this is a reduction. A little bit easier when you have the definitions in front of you. You can look at this in multiple ways. Perhaps the easiest is to just go to your definition or to Leo the Lion or oil rig. So we're going to drag that to here. It's another reduction. Now let's look at the next one. Iron is becoming F3 plus, and it lost electrons. It is losing 3 electrons, right? So the loss of electrons is an oxidation. So this iron is oxidizing to Fe3 plus. And if you want to put the labels, this is Red reduced. This is OX, oxidized. So that's an oxidation. And the last one is a little different, but you can still see where the electrons are. The electrons on these two are on the left and are being added, and we call those reductions. So what do you think this is? This is another reduction, right? So we have 3 reductions, 1 oxidation on that question. If yours is a little different and you want me to analyze it with you, please do let me know. But if you're doing this homework as we speak and it's the same question, that should be the answer. So let me submit it, get it graded, and there's a little bit of feedback there. Take it or leave it. There may be, it may be useful to you, it may be not useful. But start always with these 2 definitions, and it should help you answer the questions. Okay, there's a couple more questions related to reduction and oxidation. I want to take a look at them. This one gives you a little bit of background. I mean, this has applications in real life. Lots of biochemistry is based on redox reactions, on oxidation reduction reactions. So in the mitochondria of humans, and you probably took biology already, you know that that's the powerhouse of the cell. Energy is provided by the oxidation and reduction reactions of the iron ions in the cytochromes. Cytochromes are proteins in the electron transport chain. So we can identify each of the following reactions as an oxidation or as a reduction. Iron is gaining 1 electron, right? It's picking up 1 electron. According to this, that is a reduction. Now, I don't want to confuse you, but again, what is being reduced is the charge. It's going from 3 plus to 2 plus. The charge is reduced, but the number of electrons is going up, is gaining electrons. Okay, so that is a reduction. Approach it in any way you want to. If you want to look at the charges, look at the charges. If you want to look at the electrons, look at the electrons. But always ground yourself on these definitions. Okay? That's the best way to do it. So we're going to submit that. Let's take a look at this one. It's kind of like the opposite. It's going from 2 plus to 3 plus. So the charge is increasing, but it's actually losing an electron. So we have a loss of electrons. Loss of electrons, oxidation. So we're going to say, do you agree? Yes. It is an oxidation. And that's that for that question. You can replace that with any element, and as long as you stick with those two definitions, you're going to be okay. Now here we need to do a little bit of accounting. We may have to write this as a reaction. So we're going to write it on the board. We start with chlorine gas. And that becomes chlorine 1 minus. I'm going to balance it for you. So to go, oops, that looks like a 0. How do you become more negative? So again, always look at the atomic number so that you know the number of protons. But this guy is going to have 1 less electron than this. This has gained an electron, right? So gained electrons. So to begin with, these must have been, so gaining of electrons is a reduction. This must have been oxidized. Wait a minute. I'm getting it wrong, right?
I think you got it because it's going to get reduced.
So it's going to get reduced. Okay, so I think I got it right, but let me just regroup. It's gaining electrons, so when you gain electrons, this must be reduced. And it is getting less positive, which is, and what was that?
It's finally filling me up.
Oh. Oh my God. Okay. Now we have the labels, and now we can try to answer the question. So, let's put the electron. We don't have the electron yet. So if we add 2 electrons to chlorine 2, we're going to get 2 ions of chlorine 1 minus. We're adding electrons, we're gaining electrons, we are reducing, and all of that is there for us to answer. What would you pick as the answer?
You got the third one.
The third one. Gains 1 electron to form Cl minus from Cl2. Yeah, so this one is not balanced. It should actually say gains 2 electrons because you have 2 chlorines. So each chlorine is gaining 1 electron. Yes, I understand that. But it's actually a total of 2 electrons. So yeah, I like that. It gains 1 electron to form chlorine minus from Cl2. Elemental chlorine is reduced. Yes. or is becoming reduced? I like that answer. I'm looking at choice 1. Once again, this is because of the semantics of the question. So let's go with that one. Because it makes the most sense. I hesitated a little bit because of semantics. But remember, you have multiple attempts on the homework. Please, please, please do the homework first, the quiz second, and then go to the exam. Don't jump into the exam just because you want to be finished with the exam. All right? And again, if things get too negative for you, you get a really low score on the exam, don't panic. Email me. We can talk about it. We still have 3 more meetings where we can fix any grade.